Now we're going to look at dotsDemo, which is an application using struct. So we'll go ahead here and copy this code to begin with. And we'll go over here and paste and run it. And what we're going to do now is just show you what this does. This program, when it's running, when I click in an open area, I get a new circle. If I click inside a circle or a dot, it increases the count. So the count is the number of times I've clicked inside that dot. Notice if dots overlap, as these two, orange and yellow, do, it gives me the outermost dot. And then I'll create a new dot, and click here, and so on. Okay, so if we were going to think about how to implement this, knowing what we know about animations, we would realize that we'd have to store a list of these dots and inside data.dots. But the question is, what is a dot in terms of what information do we need to store in order to be able to draw these dots? Well, you need to have the location, the x and the y, or cx and cy. You certainly need to know the color, and it looks like you also have to know the this count, whatever we're going to call it, the click count or something like that. Though those are the pieces of information we need for each dot. So one thing we could do is we can maintain a list, and we can have the list look like so. We could have a list of, say, dots are a list, of course. You can imagine that the first dot is at location 50, 20, and it's that's its cx and cy, and its radius is maybe 35, and it's yellow, and so on. This is a bad idea because then I say for dot in data.dots. But now this dot, well, dot is really this list. So like cx, cy would be dot of 0, and the radius would be dot of 1, and finally the color would be dot of 2. This is ugly because this dot of 0, dot of 1, and dot of 2, that's ugly. Storing this in a list is ugly because when you access it, there's no semantic meaning. This code of dot of 0 does not read well at all. And if I ever, like, for instance, change the order of these, well, all my code would break as well. There's just a lot of reasons this is bad. Instead, what we'd like to do is somehow be able to say that a dot simply has a property. A dot has a cx. A dot has a cy. It has a radius and a color. So a dot's like an object with a property. And this being the week of object-oriented programming, it should come as no surprise. Well, that's exactly what we're going to do. In fact, that's what instances of structs are. A struct is a class. It's a generic class of any type whatsoever. And each time that you create a new struct, let's go ahead here when it's in mouse pressed. And in mouse pressed, right here, we're creating new dots. Okay, where a dot is just a struct. So a dot is a struct. Creating a dot means the same exact thing as creating a struct. This just allows us to give our struct a name of dot instead of struct. And when you click outside of other dots, we go ahead and create a new dot right here, a new struct. And we can initialize it with the values of x and y and rate r, fill, and click count. Once we've done this, you can actually access, for instance, dot.click count. You can access dot.x and dot.y. So dot is an object. It has properties, x and y and r, fill, and click count. This proves to be very convenient. Let's actually watch it in action. We start out with no dots. That's what init says. When you press the mouse, if it doesn't intersect any existing dots, which we'll look at in a moment, go ahead and create a new random radius and color, and then create a dot at the location that you clicked, x and y, of the given random radius, the given random color, and the click count of 0 because I haven't clicked in it yet. Then to data.dots, I append that object or that instance. Great. Now, actually what we do is first we check all the dots we have so far. And with this function we created called dot contains point. takes a dot, takes a point, and if this point inside event x, event y, if it is in that dot, just increase that dot's click count by 1, and then we're done. It's important to return there because what we're doing is we're going through the dots in reverse order. So we're going kind of like from top to bottom. And if we hit one that contains the point, we're done. You don't want to keep looking because you might find another one that it overlaps and accidentally increase that click count as well. Fine. So now we're at dot contains point, takes a dot, takes a point. Well, a dot itself has the properties x and y, and this point is out in space. You take the distance formula from the dots xy to the point xy, which is the difference of the x squared, difference of the y squared, and square root of that sum. And the dot contains the point if the distance to that point is less than or equal to the radius of the dot. That would place the point inside the dot. Excellent. So now, for redraw all, you go ahead for every dot, and you draw the oval, the actual dot, and you draw the text, which is the click count. The dot, of course, is dependent on its x, its y, and its radius, and its fill, in fact. And that's it. That is the program that will demonstrate our dotsDemo, which uses a struct class right here, a subclass of struct, and then we create instances right here of that subclass. Each dot is an object, and it is an instance of the dot class, which is a subclass of the struct class. That's all for the dotsDemo.